Okay, so before we can do this question, we need to understand a few basic concepts. The first is, what the heck does NOR mean? So we've got this word called NOR as a NOR gate, and the most important thing out of this is well, actually we've got two things. We've got the N and we've got the OR. Two different things. Now, if we look at this picture of this gate, what we recognize is that this, what I'm highlighting in yellow, is an OR gate. What I'm going to highlight in red is the N, the not, the NOR, not. So what does this mean? Well, there's different ways I can teach you this, so I'm going to teach you all of them. If we did a truth table for an OR gate, zero or zero equals 0. 1 or 0 equals 1. 0 or 1 equals 1. 1 or 1 equals 1. So basically for an OR gate, it's always going to be 1 if one of A or B is 1. We've then got a NOT truth table. And that reverses everything. So we've got A and we've got X. If you've got a 0, it will turn it into a 1. If you've got a 1, it will turn it to a 0. Okay? So, what we have is a NOR gate. So it's an OR gate and a NOT gate combined. And you might be like, what? Let me show you the first one, see if you can do some of the others yourself. Let's do this truth table. Let's do this first one. If A is 0 and B is 0, on an OR gate, 0 or 0 will equal 0. So we go through z, z. So it should give you a 0. However, we then get to a NOT part. And what does a NOT do? It reverses things. So if we've got a 0 going in, a 1 will pop out. So 1 will pop out here. So 0 or 0 will equal a 1 on a NOR gate. Because what a NOR gate does is an OR gate and a NOT gate combined. So it reverses everything of what normally an OR gate would be. So if we've got 0 or 1, normally it'll give us a 1. It's got a 0 going in, a 1 going in, it'll give us a 1. But we then face this little circle, which means NOT. That 1 will turn it to a 0. We've then got 1 or 0. This one. Which gives us a 1. So we've got 1, 0, go through, z, gives us a 1. We then face first NOT. 1 turns into a 0. So what pops out is a 0. And finally we've got 1, 1, which gives us a 1. So 1, 1 goes in, zzz, into this gate. It gives us a 1. We then have to NOT it, which then gives us a 0 again. And there we go. We've now got a truth table for what is called a NOR gate, which is this gate here. NAND works the same. I'm not going to do the whole thing, but this is an AND gate with a little circle, which means it's now a NAND gate. So if we do a truth table for an AND gate, so we're just doing the AND part. 0, 0 is 0, 1 and 0 will be 0. Remember, with an AND, both of these have to be a 1 for the X to be a 1 as well. However, if we did a NAND version, if we put this through a NAND gate, 0 and 0 would actually be a 1. 1, 0, if we put it through a NAND gate, if we put it through here, if we did 0, 0, 0, but it goes through this, so it turns it to a 1, etc. But this question was about a NOR gate.